All right, so we are zooming through this next section so fast. I know that this unit is like so day after day after day, just like new lesson. We're going so quickly through it. But I feel like these lessons are pretty straightforward and pretty easy. I don't see a need to spend 2 days on these, so unfortunately we are going pretty quick. I tried to lessen the number of questions in each section. I hope you've noticed that and aren't feeling too overwhelmed at this point. So for this section, there's just 4 questions that I picked out on the distributive property. There's no homework questions to do. I just saved like the last little section for you to just try something on your own instead of just copying what I'm saying in a video. So for this first one, at a department store, you purchase the following items with the prices $13, $73, and $27. An 8% sales tax in your state is applied to the subtotal. Will the final cost be affected by whether the tax is added to each item separately or if the tax is applied to the subtotal? So is it going to make a difference if we apply tax kind of before or after? So those are the 2 things we're looking at. Separately, or we're just adding it all up and applying it at the end. So if we added the tax to each item separately, I'll take the $13 and multiply it by the 8%. So 1.08. Remember, the 1 is because we're taking the whole, we're taking the $13 and then applying the 8%, which is as a decimal, 0.08. So with sales tax, that item is $14.04. We'll do the same thing for the $73 item, $78.84, and the same thing for the $27 item, $29.16. So we took each of the 3 items separately and added sales tax separately to each item, and then I can add it all together for a total of $22.04. And then we'll compare it to, well, what if we just add the sales tax at the end? So I'm going to add up all 3 of the items that I bought, and that's $113. I'll add the tax on at the end, so the 113 times the 1%, and $122.04. Notice that it's the same price, so it doesn't matter when we add in the sales tax, the total will be the same in either model. Scrolling down, some real life distribution property if you want to read through the examples. Distributive property definition, laid out algebraically for you with just some variables, no numbers, with numbers, distributive property. If you want to read through that, if you're feeling confident with the distributive property, you can just jump down to number 2. I'm pretty sure most of you should be able to do these by yourself, but just in case, I will go through them quickly through the video. So we've got 3 times everything in the parentheses. So the x squared minus the 4x plus 1. So I'll distribute the -3. Make sure you're including the negative. That would be the biggest problem I anticipate seeing, which hopefully at this point you're not making that mistake. So we'll distribute it to all 3 terms in the parentheses. So our final answer is -3x squared plus 12x minus 3. Pretty simple. B is negative, and we can always imply a 1 so that we're distributing a number if you want to, or you can just distribute the negative. But if you want to see a number, just throw in a 1 there. It doesn't change anything. 3 times 1 is still 3. 4 times 1 is still 4. Doesn't matter if we multiply by a 1. So I'll distribute the negative through the terms in the parentheses. So I've got 4 plus 7. I can simplify, and I get an answer of 11. C is pretty much the same thing. 10x will distribute to each of the terms in the parentheses, and I get 10x cubed minus 50x squared plus 60x. Notice that each of the terms, we did need to distribute that x in as well. It wasn't just a number. Part D is kind of backwards. So I'm going to distribute the 2 going to the left. So I'll distribute it to the 8 and the x just like I did before. So 16 plus 2x. Part E, we have 2 sets of parentheses that we need to distribute. So I need to distribute twice. So the first one will distribute the 4. The second one will distribute the 6. So I get 12 minus 8i plus 48 minus 6i. And then I simplify, which is combining like terms. And my final answer is 60 minus 14i. And then very similar, just a little more stuff going on in this one. I'll distribute twice. I'll first distribute the 2x, and then I'll distribute the negative 5. So I'll get 12x to the 4th minus 8x squared plus 22x, and then minus 5x minus 45. I've got the like terms. I'll combine them together to create that plus 17x. And cruising right along, I'm actually going to skip number 3. It's not, if you want to give it a try just to practice on your own, you can absolutely try number 3. I didn't think it was anything new or earth-shatteringly difficult, so I decided to just skip it. If you need still more help, this one is finding the product of 2 binomials. So notice that we have 2 sets of parentheses. So we'll go over that in the next example. When I learned this, I learned the FOIL method, but when I taught Math 2 a couple years ago, nobody ever used the FOIL method. It just stands for first, outer, inner, and last. So if you need a description of that, you multiply the first term, so the x times the x, the outside, so the x times the 3, the I is the insides, and then the L is the last terms. If you want to use that just for a mnemonic, you totally can. Otherwise, pretty much, I think the way I taught it was just everything gets multiplied by everything, and it seemed to work for most, hopefully. So I'll take the x and I'll multiply it by the x and then the negative 8, and then I'll take the negative 2, multiply by the x, multiply by the negative 8. So I get x squared minus 8x minus 2x plus 16. I can combine like terms, x squared minus 10x plus 16. And then we have part B. This one is a binomial, so 2 terms multiplied by a trinomial, which is 3 terms. If you want to pause the video now and try it out yourself before I give you the answer, I think that would be a great idea. Otherwise, just keep watching. So we'll multiply the x by everything in the next set of parentheses, and then we'll multiply the 1 by everything in the second set of parentheses. There you go, x cubed minus 2x squared plus 1x squared minus 2x plus 1. I don't need to include the 1 in front of the x. I just did, just in case anyone wanted to see that. Combine my like terms. There we go. There's my answer. And then the last one, I'm going to leave B and C for you to try out on your own just to make sure that you're understanding things and not just copying exactly what I'm saying on screen. But for each of the following problems, use the box method, which I'm not the biggest fan of the box method, but I know some students really love it. So use the box method for multiplying polynomials. For each missing term outside or inside the box, then write the area of the box as a product of the sum. So I know that seems like a lot, but it really isn't bad. So we need to fill out the outside of the box and the inside of the box. So we have the 3x, that's on one side of the box, and then the 3 inside squares are filled in. So we're really just looking at the top 3 outside of the boxes. So 3x times what gives me 6x cubed? And that would be, hold on, my pen is off. Okay, 2x squared. So 3 times what is 6? 2. X times what is x cubed? X squared. So we'll do the same thing. 3 times what is negative 3? That's negative. We just went from positive to a negative. And then x times what is x squared? X. So I get negative x or negative 1x, either or. And then 3 times what is 15? 5. X times x is just itself, so I'm not adding anything there. And then the last part, then write the area of the box as a product of the sum. We're pretty much just writing the side times the other side. So length times width gives me the area of the box. Again, not my most favorite method, but students do seem to really like this method. So it's just multiplying those two. So go ahead and give part B and C a try on your own.